दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, we have discussed in our last class the radicals, compound radicals, and simple electropositive, electronegative, and electronegative compound radicals, and how to write the formula of a molecule from the atoms or from the radicals available. We have discussed that we will take the basic radical B plus N, acid radical we have taken as A minus M. So the formula will be BMAN. We first write the basic radical with its charge at the top, and then acid radical A with its charge at the top minus M. Then we exchange the number of the charge and writing them at the bottom BA. So BMAN is the formula. And taking this compounds, we have tried to write the formula of many compounds with different radicals, both basic radical, acid radical. We have discussed also what are oxides, what are acids, bases, and salts. We have discussed broadly the acids. The acids are the compounds which contain replaceable hydrogen atom. The replaceable hydrogen atom is one which can be replaced by a metal atom, or in other words, acids are the compounds which donate H plus ion and the proton in their aqueous solution. The proton lost by the acid is accepted by the water molecule, forming hydronium ion or hydronium radical. So in the aqueous solution, the acid, if you take HX, H is the H and X is the acid radical, then we get the H3O plus and X minus. So X minus is the negatively charged ion present, comes from the acid, and it is a radical as it is a charge, so we call that as acid radical. So now the acids can be of, how to write the formula of acids, that I have told you in my last class. All acids can be of two types, hydra acid and oxy acid, depending on the constitution. All ID radicals combine with H plus form hydra acids. F minus, the fluoride, combines with H plus to form H of hydrogen fluoride and hydrochloric acid. Cl minus chloride combine with H plus form HCl, hydrochloric acid. Br minus bromide combine with H plus to form HBr, the hydrobromic acid, and I minus, the iodide, combine with H plus to form hydroiodic acid, HI. Now coming to Cn minus, cyanide combined with H plus to form HCN, hydrocyanic acid. Now coming to, these are the hydra acids we have. Now coming to the other type of acid, oxy acids. All oxy anions combine with H plus to form oxy acids. So we have two type of radicals, that IT radical and AT radical. IT radical, they come from the lower valence state of the element, and AT radical, they are formed from the higher valence state. All AT radicals, they form IC acid, and all IT radicals, they form OUS acids. So name of the radical minus AT plus IC acid will give us the name of the acid. Very easy. From the radical, if you go to write the formula, write the name of the acid, it becomes very easy. Now I have taken the example BO3 minus 3, borate. So H3BO3 called boric acid, or BO2 minus is metaborate, and HBO2 is metaboric acid. Now coming to group 4, we have carbonate, CO3 minus 2, 2H plus combines with CO3 minus 2 to form H2CO3. It is carbonic acid. Carbonate minus ATE plus IC acid, carbonic acid. Silicate SiO3 minus 2 combines with H plus forms H2SiO3 silicic acid. Now in group 5 we have nitrogen and phosphorus, two elements. They form the oxy acids. Nitrogen forms nitrate NO3 minus and then NO2 minus nitrite. NO3 minus combined with H plus to form HNO3, the nitric acid. NO2 minus, the nitrite, combined with H plus to form HNO2 nitrous acid. Phosphate forms phosphate PO4 minus 3, PO3 minus 3 phosphite. PO4 minus 3 combined with 3H plus to form H3PO4, the phosphoric acid. And phosphite PO3 minus 3 combined with H plus to form phosphorus acid. Now then comes, we have discussed about the group 6 elements. The sulfur forms radical sulfate minus 2, 2H plus, it combines H2SO4 sulfuric acid. SO3 minus 2 sulfite, it forms H2SO3 sulfurous acid. Now it has two other radicals, H2O3 minus 2 thiosulfate combines with H plus S2O3 thiosulfuric acid. S4O6 minus 2 tetrathionate combined with H plus to form tetrathionic acid. Now two other radicals are if you come to the 6B group of the periodic table, we have three elements, chromium, molybdenum and tungsten. They form the acid radical, AT radicals, chromate CrO2 minus 2, MO4 minus 2 molybdate and WO4 minus 2 tungstate. So the CrO4 minus 2 combined with H plus, 2H plus to form S2CrO4 chromic acid. Cr2O7 minus 2 dichromate combined with H plus 2S2Cr2O7 dichromic acid. Molybdate MO4 minus 2 combined 2H plus to form S2MO4 the molybdic acid. WO4 minus 2 tungstate combined 2H plus to form S2WO4 tungstic acid. Now if you go to the group 7, we have chlorine does not form oxyanion because fluorine does not form oxyanion because fluorine is more electronegative than oxygen. So oxyanions are formed by chlorine, bromine and iodine. So perchlorate, chlorate, chlorite, hypochlorite. So ClO4 minus perchlorate combine H plus form SClO4 perchloric acid. ClO3 minus chlorate combined H plus SClO3 chloric acid. ClO2 minus chlorite combined H plus HClO2 chlorous acid and Cl minus hypochlorite combined H plus to form hypochlorous acid. Similarly, per bromic acid HbRO4, bromic acid HbRO3, bromous acid HbRO2 and hypobromous acid HbRO. Similarly, HiO4 iodic acid HiO3 periodic acid HiO3 iodic acid and iodous acid HiO2 and hypoiodous acid HiO. And we have the manganate MnO4 minus 7B. We have the permanganate MnO4 minus 1 HMnO4 permanganic acid. So how nicely we could write all the formulae of the AT and IT radicals. Now we will now discuss today's class the oxides. Base, we have discussed also bases. Bases are the compound oxides and hydroxides of the metals. So all the elements, metallic elements, electropositive elements combine with oxides and hydroxide to form the bases. And all the group 1 element, they have the lithium, sodium, potassium, rubidium, cesium are highly electropositive metals. LiOH lithium hydroxide, sodium hydroxide, NaOH potassium hydroxide, KOH, RbOH rubidium hydroxide, CSOH cesium hydroxide. All these are strong bases. Those bases which are soluble in water, they are called as alkalis, and these elements are called as, that's the reason they are called as alkali metals. Now group 2 elements, beryllium, magnesium, calcium, strontium, barium, all these elements are also highly electropositive divalent metals. they form their hydroxides, the magnesium hydroxide MgOH2, calcium hydroxide CaOH2, strontium hydroxide SrOH2, and BaOH2, barium hydroxide. All these are strong bases. So these are the things we have discussed. What are the acids and bases? Now today's class we will discuss, we are going to discuss how to write a balanced chemical equation, or how to write a chemical equation and how to balance a chemical equation. So to know what is a chemical equation and balanced chemical equation, prior to that a student should have the knowledge of oxides, because many often while writing the chemical equation we require knowledge. I don't want to impress upon you remember the equation and write. I want that you will write the, you will write the equation yourself. You will predict the product. The products, I will not give you the product. I will give you the reactant, and having the basic knowledge which I have given you in all these classes, taking them, you will write the product yourself and balance the equation. That is my point of balancing chemical equation. So before that, let me teach you what are oxides, because this is a very important topic. What are oxides? The oxides are the chemical compounds. Oxides are chemical compounds formed when an element reacts with oxygen. So it is a chemical compound when an element reacts. Now the elements are of different types. So depending on the type of the element which reacting with oxygen to form the oxide. Suppose you have the element, we have the element say E, and it is combining with O to form EO. Will form the compound EO. So this is the EO general compound. So these elements are of different types. We have seen the periodic table. Atoms of the elements have a strong tendency to take part in chemical combination, either by losing or gaining electron, or by contributing and sharing electron. So this element, when it is combining with oxygen, it may lose or gain electron and take part in chemical combination, or it may contribute and form and attain octet to form the oxide. So depending on the type of element, so when an element is losing electron, combining with oxygen, it is an electropositive element and they are metallic in nature. And when an atom of element gains electron and takes part in chemical combination, is called as electronegative element, and they exhibit non-metallic character. Hence I say, depending upon the type of the element or the nature of the element, the oxides are of different types. So why the oxides are of different types? Because depending on the nature of the element may lose electron spontaneously, or may lose electron ordinarily, or may lose electron with difficulty, or will accept electron, take part in combination with oxygen. So depending upon the element, depending on the type of element, the oxides are of different types. different types. Why? Now as they exhibit different properties. So we are considering their properties. We are considering the type of element, and we are then are oxides. So these, depending upon the type of element, whether it is electropositive or electronegative, or midway elements are metals, non-metals and metalloid. I have told you, if you go to group 4, carbon, silicon are non-metals, germanium is a metalloid, tin and lead exhibit metallic character. Between tin and lead is more metallic than tin. Between carbon and silicon, the carbon is more non-metallic than silicon. So now you see, they belong to same group of periodic table. They have 4 electrons in their outermost shell. They will exhibit same type of valency. They will form the formula, oxide of the formula different, but the nature of the oxide will depend different, because a tendency to lose electron, a tendency to gain electron is different for different elements. So depending upon the type of elements and the type of oxide, the properties of the oxide formed. Now these oxides are of different types. They can be acidic, basic oxide. They are called as basic oxides, and acidic oxides, neutral oxide, amphoteric oxides, and neutral oxides. Depending upon the type of element and the properties the oxides exhibit, they are basic oxides, acidic oxides, amphoteric oxides and neutral oxides. So now let's come to first go one by one. What is a basic oxides, acidic oxides, amphoteric oxides and neutral oxides. Which oxides are basic? Which metals will form basic? Which elements will form basic oxide? Which elements will form acidic oxide? And which are the elements will form amphoteric oxide and neutral oxide, and how the behavior they differ. Now coming to, let's first start with the basic oxides. All the electropositive metals, all the electropositive elements, what are these electropositive elements? Are what? They are metals elements. Who are electropositive elements? The atom of the elements which have a tendency to lose electron, they are called electropositive elements. React with oxygen to form basic oxides. Then which group? Now we will come to electropositive. All the elements of group 1. All the elements of group 1A, they have 1 electron in their outermost shell. Who are they? Lithium, sodium, potassium, rubidium, cesium. I told you, if you go down the group, you have lithium, we have sodium, potassium, rubidium, cesium. We are going down the group. Electropositive character increases. When you go down the group, the electropositive character increases. For example, if you go to the earth and dig the earth, The moment you go on digging the earth, you will feel the heat is increasing. Exactly here, when you go down the group of the periodic table, the electropositive character of the elements increases. Why? Their size of the atom is increasing. Number of cells are increasing. Shielding effect is increasing. So the tendency to lose electron increasing. So electropositive character increasing. So the CGM, you will have the most electropositive element of the periodic. Any group you go, any group, there is the tendency down the group, electropositive character increases. So now lithium will form lithium oxide. So lithium oxide and sodium oxide, potassium oxide, rubidium oxide and cesium oxide. All these oxides, they are strongly basic. They are strongly basic because they are highly electropositive metals. So they are strongly basic. They are soluble in water to produce hydroxides which are strong bases, hence these are called basic oxides. They are called basic oxides. And any base soluble in water is called as alkali, strong bases. They are alkaline. They are alkaline in nature. They are alkaline in nature. Why? Any base soluble in water is called as an alkali, and all they are soluble in water, they are strongly basic and alkalis. For example, write just one equation. I am writing, I will take sodium oxide and I will put into water. So you know that sodium is positive, oxygen is minus, negative, hydrogen is positive, oxygen negative. So the sodium, so this water contains H plus, OH minus, so this forms NaOH. This forms NaOH. So you will have 2 NaOH, sodium hydroxide. Similarly, when you take K2O, the potassium hydroxide will react with water to form 2KOH. So this is a chemical reaction because it is a reactant, they form the product. So this we call as the chemical reaction, and you are writing in the form of an equation, hence it is called chemical equation. So we are going to learn chemical equation, we are going to learn balancing chemical equation. For that we want some fundamental concepts. Now coming to group 2A elements. Who are they? Beryllium, magnesium, calcium, strontium, barium. Radium is there, but radium is a radioactive element, so I am not considering it. All these they react with oxygen to form BeO, MgO, calcium CaO, SrO and BaO. Barium oxide, strontium oxide, calcium oxide, magnesium oxide, beryllium oxide. Now the moment we add water to this, so this will form barium hydroxide, this will form magnesium hydroxide, this will form calcium hydroxide, this will form strontium hydroxide, this will form barium hydroxide. All these are strong bases. Hence are called as alkalis. And down the group, if you go to the down the group, their basic character is increasing. If barium hydroxide and beryllium hydroxide, the barium hydroxide is strongly basic. If you consider the magnesium hydroxide, this is a base, this is an alkaline nature, but barium hydroxide is more basic than magnesium hydroxide. Now these are the strong bases. they are basic oxides. Now we'll come to acidic. In any group you go, the same thing happens. So generally these are the strong bases available, highly electropositive metals, they form basic oxides. Now we'll come to acidic oxides. All the electronegative elements, who are they? They are also called nonmetals. They have a tendency to gain electron. They are called as nonmetals. React with oxygen to form acidic oxides. Why acidic oxides? Now because that oxide is exhibiting acidic property. What is acidic property? It turns blue litmus red. These oxides are soluble in water. These oxides are soluble in water to form their oxy acids. To form their oxy acids. The electronegative elements, who are they? Group 4, group 5, group 6, group 7. These elements are electronegative elements. Their oxides are non-metallic oxides, and they are acidic oxides. They react with water. They are soluble in water to form oxy acids. They are soluble in water to form their oxy acids. Let's take the one or two example and write them and see here. If you come to say carbon dioxide, carbon reacts with oxygen to carbon, combines with oxygen to form carbon dioxide. Carbon dioxide is a non-metal. Carbon is a non-metal. Carbon is a non-metal, so electronegative element. Combines with oxygen to form CO2. So the carbon dioxide is an acidic oxide. So this reacts with water. To form H2CO3, carbonic acid. This forms carbonic acid. Carbonic acid. Similarly, if you come to silicon, forms silicon dioxide. It is an acidic oxide. This is soluble. This reacts with water to form H2SiO3, silicic acid. Now if you come to the first P2O3, phosphorus combined with oxygen to form P2O3. This reacts with water to form H3PO. It will combine with water H3PO3, phosphorus acid. This will form phosphorus acid H3PO3. This will combine the water to form phosphorus acid. Similarly, you have P2O5, phosphorus pentoxide. Phosphorus pentoxide is an oxide of phosphorus, and phosphorus is a non-metal. Phosphorus combines with oxygen to phosphorus pentoxide. 2 phosphorus combined with 5O2 to form 5O, or you can say P2O5. P2O5. We have 2P, 5O, you can write like this. Why are you getting confused? So P2O5, this is phosphorus pentoxide. This atomic equation. We'll make it molecular to multiply this. So if you will get the equation, you will write 4P, 5O2 will form 2P2O5. This is the equation for how it forms. So this phosphorus pentoxide is a acidic oxide. How? Now if you take P2O5, if you add with water this will form the acids of phosphorus, oxy acids of phosphorus. They'll form oxy acids of phosphorus. P2O5 plus water. If you take P2O5 plus water, three water, this will form 2H3PO4, phosphoric acid. Phosphoric acid. So you have 6 hydrogen, 2 phosphorus. This is called phosphoric acid. Similarly, you have the oxides of nitrogen, N2O5, nitrogen pentoxide, soluble in water. They form nitric acid. They'll form nitric acid. Nitric acid. Similarly, when you come to sulfur dioxide, you have the example of sulfur combines with oxygen to form sulfur dioxide and the sulfur trioxide. This sulfur dioxide is an acidic oxide. Sulfur trioxide is an acidic oxide, and this forms H2SO3, sulfurous acid, and this forms with water, this forms H2SO4, sulfuric acid. It forms sulfuric acid. This forms sulfurous acid. If you take SO2 and water, this forms sulfurous acid, H2SO3, and we have SO3 plus water, and this forms H2SO4, sulfuric acid. So these are all the nonmetallic elements react with oxygen to form the nonmetallic oxides. They are acidic oxides. They are soluble in water to form their oxy acids. Now we'll come to the because I am doing this only, I will be teaching you soon after this class. I will be teaching you how to write a chemical equation and how to write a balanced chemical equation. So my point is, what happens generally, students, they are in habit of remembering the equations, but my point is that we will try to write the products ourselves. What will be the product, what will be the products possible, we will try to write that. We will try to get the equation ourselves and we will balance the equation. So if we do it successfully, children, I can assure you that you will never feel frustrated, or you will never feel dejected, or you will never feel backward, or never feel to remember equations. You will never tell that chemistry is difficult, because that is the only place where the chemistry gives a kick to the students, where the students, they get confused with writing balancing chemical equation, because they straight jump to write balancing chemical equation, but you have to get equipped to write the equation. So these are I am making you equipped with the fundamental concept, and whenever we are writing the equation, we will use these concepts and write the chemical equations, and we can balance them. Now let's come to the third type of oxides, are amphoteric oxides. Amphoteric oxides. Those oxides which exhibit both acidic and basic properties. Acidic and basic properties are called as amphoteric oxides. Amphibians. Amphoteric, you have read the word in your biology, amphibians. MPO means both. In two opposite environment, if one is existing, This we are use the word MPO. Suppose somebody is remaining in water and outside water, so we call them as amphibians. So here also the amphoteric, AMPHO, amphoteric oxides. Those oxides which exhibit both acidic property, means what? They will react with base, and basic property, means they will react with acids. So to form the they are called amphoteric oxides. So what are these amphoteric oxides? These amphoteric oxides, these oxides react with acids and bases to undergo neutralization. So they are called as amphoteric oxides. So who are they? Now group 3, it starts with group 3. Aluminium forms aluminium oxide. Aluminium forms a boron is a purely non-metal. It forms borate, metaborate. Borate react with water to form boric acid, and metaborate react with water to form metaboric acid. They are acidic. Borate. Now when you come to these oxides, these are aluminium, for react with oxygen to form aluminium oxide. Aluminium oxide. This aluminium oxide has the character to react with acid, also to react with base. It reacts with acid, so it is exhibiting basic property. It reacts with base, also as exhibiting acidic property. So one such example I am taking you, aluminium oxide. Aluminium react with oxygen to form Al2O3, aluminium oxide. So you have 2Al, 3O forms Al2O3. So this is a equation you are writing. So if you make it a molecular equation, balanced equation, this will be 4 aluminium plus 3 O2. And how I am doing it, I am going to teach you in next class this 2Al2O3. So this aluminium oxide is an amphoteric oxide. This aluminium oxide react with both acid and base. This is a chemical equation. And what I have done, that is called writing balancing chemical equation. So now you see aluminium oxide react with water to form aluminium hydroxide. Aluminium oxide, how many aluminium are here? 2 aluminium. So multiply this by 2. How many OH are this side? 6. So multiply this by 3. How many 3 to 6? 6 hydrogen you have here. So may multiply it by 3, you will have this aluminium hydroxide. So this aluminium hydroxide react with acid. This aluminium hydroxide reacts also with base. This aluminium hydroxide, if you take aluminium hydroxide, add acid, HCl, hydrochloric acid is an acid. So this forms aluminium chloride and water. Aluminium chloride and water. So you have 3 water and this is 6 HCl. So you will have 3 HCl. Sorry, 3 OH. So 3H, 3 water, and you will have aluminium chloride. Now this aluminium chloride, this is a acid. So this is acid. This is what? This is a salt. Why? This is aluminium basic radical, chloride acid radical. So they form the salt, and so this must be a base. This is base. Aluminium hydroxide is exhibiting basic property. Now same aluminium hydroxide, if you take aluminium hydroxide and if you add the sodium hydroxide, this forms sodium meta-aluminate, NaAlO2 plus water. So 2 water, how many? 4 hydrogen. So 2 water remains. So 4 hydrogen 4 hydrogen balanced. So this is a salt. So this is a -1 and this plus 1. This is a basic radical, this is a radical. This comes from where? This comes from here. So this sodium hydroxide is what? It is base. Is a base. And what is this? A salt. So then what it must be? It is exhibiting now acidic property. It is exhibiting which what property? Acidic property. Though hydroxide, it is exhibiting acidic property. If you take, I will show you if possible in one class, aluminum hydroxide is a precipitate. If you go on adding, you go on adding sodium hydroxide to that, it will dissolve, will form a clear solution, sodium meta-aluminate. So this is a salt. So we say that aluminum oxide is a what? Is a amphoteric oxide. Similarly, another example we can take zinc oxide. Zinc oxide is another example which is also an amphoteric oxide, because this zinc oxide reacts with acid. So if you add sulfuric acid, so this forms zinc sulfate plus water. This is called a chemical equation, and I am writing the equation now. So this is zinc plus 2, oxygen is -2, hydrogen is +1, sulfate is -2, zinc is +2, and sulfate is -2. So zinc is +2, will react with whom? With sulfate, and O is minus, will react with whom? With H plus. So zinc sulfate. So this is what? This is an acid, and this is what? This is a salt. So acid reacts with whom? Base. So here zinc oxide is exhibiting basic property. It is acting as a base. Now if you take same zinc oxide, we'll add them to sodium hydroxide. Sodium hydroxide will form Na2ZNO2, sodium zincate plus water. So this will form Na2ZNO2, sodium zincate. This is called sodium zincate, a salt. Sodium zincate, a salt. And so this is what? This is a base. And what this must be? This must be acidic. So zinc oxide is exhibiting acidic property, is also exhibiting basic property. So all the oxides, they form this. Now if you come to group 4, germanium forms germanium oxide, which is also a amphoteric oxide. Tin oxide, SNO, is also an amphoteric oxide. So the oxides, those are electronegative, those elements, there are some elements, they form this. There are few amphoteric oxides are there. Then comes the last is one, neutral oxide. Those oxides are neither acidic nor basic. They are called as neutral oxides. There are very, very few oxides. Those oxides which are neither acidic, neutral oxides. So those oxides which are neither acidic nor basic, they are neither acidic nor basic. They are called as neutral oxides. They are called as neutral oxides. There are very few. One example I can give you: carbon monoxide. Carbon dioxide is acidic. Carbon dioxide react with water to form carbonic acid, acidic. So carbon dioxide is an acidic oxide. Carbon dioxide reacts with oxygen to form carbonate, acidic radical. But carbon monoxide, CO, carbon monoxide, is a neutral oxide, because it does not react with acid, does not react with base. In one reaction, the carbon monoxide exhibits acidic property. A question will come in your entrance exam: name the oxide, name the neutral oxide which exhibits basic acidic property in one reaction. It is when carbon monoxide forms sodium hydroxide, forms sodium formate. That we will read when we will read organic chemistry. We will come to that. That is the only reaction where the carbon monoxide forms. But carbon monoxide, for all practical purposes, it is nitrous oxide is also a neutral oxide. There are few examples of neutral oxide. We are now interested in this because we will be writing the chemical reactions. So we will have an acids, acidic oxide, basic oxide. Acids react with base to undergo neutralization to form the salt. So this we have done the oxides and how the acidic oxide, basic oxide. Next class, children, I will teach you what is salt for 2-3 minutes. Then I will go to how to write a chemical equation. Then we will study how to balance a chemical equation. That is the real chemistry part of the subject. That is the real chemistry of the subject. So that we will learn in our next class what is a chemical equation, how to write a chemical equation, how to balance what is a balanced chemical equation, then how to balance a chemical equation. In 4 type of steps we will study. Before that we will study what is a salt, then we will proceed to write a chemical equation. Thank you very much for your nice listening.